Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. This is Dr. Ahmad Al Faris. Today we're going to answer the paper February-March 2019. اوكي كل عام وانتم بخير واتمنى انكم كلياتكم تجيبوا نتائج رائعة زي دائما. In this paper we have a lot of questions, okay, that has unique ideas, and a lot, also we have several questions that they keep repeating ideas. First question, for example, define acceleration. Now, all of us knows what's the definition of acceleration is the rate of changing what velocity. You can send me on the chat. Yes, thank you, Muhammad. The rate of changing, I'm sorry, there's something wrong. Okay, here. The rate of changing velocity. Okay, the meaning of the rate divided by time, changing velocity, I mean by speed and direction here. I'm sorry for my handwriting, there's something wrong here. Okay. Now, then what they ask? Part B. The figure shows the distance, okay, time graph for the journey of a cyclist. This is the distance, and this is the time. The time is 40 seconds, and the maximum distance is 300 meters, okay? The distance traveled from 0 to 300. What do they ask? First, describe the motion of the cyclist between 0 and 15 seconds. As you can see here, it's curved, and the gradient becomes faster. Yes, thank you, Anas, thank you, Muhammad, thank you, Marwan. So because it's curved, that means the gradient get increasing. So that means you can write acceleration, you can write increasing speed, okay, acceleration. You can write increase in speed. I don't know why I have problem today. Acceleration. Yes, or speeding up. Okay, now from the time 15 seconds to 30 seconds, from here to here, you can see that it's a straight line. That means steady speed or constant velocity, steady speed or constant velocity. Okay, and from 30 to 40, you can see that here we have what the gradient is decreasing. It's curved down. That means every second the gradient decreases. That means deceleration or slows down. So deceleration. I am sorry, my handwriting is not that good. So I will switch from writing to typing. Okay. So in the first one here, it is acceleration. Acceleration because the speed increases. Acceleration. Okay. The second one here, it's what? Steady speed or steady velocity. And steady velocity. And the one here, okay, it's what? Deceleration or slowing down. Ration. Or you can write what? Slowing down. Good. Okay. Now that's it for part A, 3 easy marks, 1, 2, 3 marks. Then what they ask? Calculate for the 40 second journey, the average speed and the maximum speed. When they said about average speed, we know that average speed or average velocity, it's equal what? It's equal to the distance, okay, divided by what? Distance divided by what? Divided by time. So distance over what? Over time. And we know that the distance here, since we are talking about the whole journey, it's a 300, the total distance, exactly, divided by what? Divided by the time, which is 40 seconds. And the answer will be how much? Okay, I'm sorry. And the answer will be what? 7.2. Okay, if I want to divide what distance over time, and divided by time, so it's 7.5 meters per watt per second. And the maximum speed is where the line is the steepest. In this region here, from here to here, the line is the steepest. So I'll take the gradient. It's from 15, and the value here, it was 70. Yes, 70. Okay. A lot of people, they try to send me messages now. Okay. Until the time which is 30. Okay. And it's what? 250. So I took the gradient of this straight line here. Okay. From this point to this point, and I will find how much is the maximum speed, because the gradient is the maximum of this situation. Yes. So it will be chain delta, or chain V minus U over what? The total time here, or the time for the, okay, for this, I'm sorry, not V minus U, I'm sorry. It will be distance divided by time, and the distance here, okay, divided by time, the distance here, which is equal to 250, okay, minus 70 over what? 30 minus 15 from the gradient, and the answer, it will be how much? It will be 12 meters per second. Okay. Okay. Any questions so far? Tamam. Can we do it again? No problem. I will do it again. So what do we have here? We have what? As you can see here, I'll change the color. Okay, Bassem, yes, تفضل. You can send me on the chat. What do you want? Okay, so we have the change in the displacement, okay, when it's constant speed, when it's a straight line from here to here, and this region we have a straight line. When we have a straight line, that means the speed is constant and it's maximum because it's a steeper. It's from 15 with 70, okay, and it finish when it's the straight line finish at 30. And as you can see, it's with what? With 270 at this point. So we'll take the gradient, which is 250 minus 70 over what? The time, which is 30 minus what? 15, and the answer will be what? 12 meters per second. Yes, Basim, what do you want? Okay. Send me on the chat if you please. Okay. You are welcome. No problem. Next question, question number 2. What do they ask? State one advantage and one disadvantage of using a wind turbine as a source of electrical energy. Now we know that electrical energy, okay, by this wind turbines, okay, we have a lot of advantages. Who can send me some of the advantages here? Who can send me? Okay, I read what you want. Khaled, you can, Bassem, sorry, you can write down these or take a screenshot if you please. Okay, one of the answers that Salma said that the advantage is renewable, doesn't run out, it doesn't produce carbon dioxide, renewable energy. The disadvantages are low efficiency, okay. Type. Now we are going to talk about the advantages and the disadvantages of this question. Question number 2, what do they ask? State one advantage and one disadvantage of what? Of the wind turbine. Now most of you ask me about, send me correct answers. The advantages that it doesn't use fossil fuel, it doesn't cost fuel cost, there is no fuel cost, okay, it doesn't make a pollution or produces carbon dioxide, okay. Also, it is a renewable energy source, as most of you told me, yes, okay. And don't forget, okay, it does not contribute, okay, the global warming, or it doesn't affect the gases of greenhouse effect, or okay. So you can write any answer. For example, it is renewable, okay. I have a problem with my pen. I don't know what's happening here. So we can write renewable energy, and doesn't, what's this? Yes, renewable, okay, renewable energy, and doesn't produce, and there's no what carbon dioxide or no pollution, no pollution. Yes, polluting gases. Okay, that's an answer. We can write it for this part for the advantages, but for the disadvantages, what we can write, that exactly a lot of you give me correct answers. That it's expensive in the beginning, build it exactly in the beginning, okay, or it has low efficiency, or it can make a pollution for the vision, okay, for us to see it, okay, or there's there's always wind, it doesn't blow at constant speed, okay. So you can write, okay, one of these disadvantages, okay. For example, what I'm going to write, what, okay, I'm going to write wind do not have constant speed of blowing. Okay. Yes. Constant speed of blowing. Tamam? Yes, thank you. Can we say it's unreliable? Now, usually you have to write down the most answer that is common on the mark scheme, and we don't know the mark scheme when we do the answer. So you have to write something that's relative to the question. Okay. Now, if it's not reliable, we are not going to use it in the word, but a lot of countries they use it. That means it's reliable. Okay, reliable. Now, what do they give us? They say that the speed of the wind is 16 meters per second. They show a wind turbine, and this is the wind. It's swept out by an area, okay, for the turbine blades, as you can see. Part I, okay, what do they say? The wind blows, okay, at what? At a speed of 16 meters per second towards the turbine blades. At 1 second, the volume, okay, every 1 second, the volume of the air passing here is what? Is 24,000 meter cube, okay, of air. Tamam. And the density of air, it's 1.3 kilogram per cubic meter. This is the density, and this is the volume, okay, and this is the speed every 1 second. What do they ask? Calculate the mass of the air that passes through the circular sweep out of the blades every second. Now we know that density equal mass over what? Over volume. So by putting the mass as a subject of the formula, so mass equal, I'm sorry, I have problem with the pen. Okay, so I'll write that the mass is equal to the density multiplied by what? Multiplied by volume. And by using the calculator, the density, which is 1.3, multiplied by the volume, which is 24,000. And the answer, it will be what? How much? 31,000 kilogram. Yes, thank you all for answering. Okay. Then what I can say here? They ask about part B, okay? They ask about calculate also the kinetic energy, okay, of this mass passing what? The kinetic energy passed every second of these plates. And we know that kinetic energy, by using the formula, what's the formula for kinetic energy? Yes, half mv squared. Excellent, ya shabab. So we can say that Ke is equal half multiplied by mass multiplied by the speed squared to the power of 2. Okay. And as we know that the speed here, it's given 16. So we will write down the answer, and it will be half multiplied by the volume, the mass that we just find it out, 31,000 multiplied by what? 16 times another 16, or 16 square. And by using the calculator, it will be 400, or sorry, 4 million joules. Or you can write it 4 times 10 to the power of what? Times 10 to the power of 6. Good so far? Any question? Unfortunately, I have problem now with my pen. I don't know why it's not writing. Okay. What do they ask here? Okay, so now suggest why some of the kinetic energy of the air, okay, some of the kinetic energy of the air that passed through the circular area swept out by the plate is not converted all of it to electrical energy. Now we can say that not all the air that swept stops, okay? That means if it stops, that means it has kinetic energy, and now it stops, that means all the energy is converted to the plates, and that's not happening. Or you can say that some of the air molecules, they keep moving without touching the plates or hitting it. So these two reasons are the main reasons why not all the energy is transferred from what? From the air as kinetic energy to what? To electrical energy by this device, or this generator here, the wind turbine. So what I'm going to write here, I'll say that not all the air hit the plates, and they didn't stop, and still have what? Kinetic energy. So because of this, because they still have kinetic energy, that means not all the kinetic energy is transferred to what? Yes, not all the kinetic energy is transferred to be electrical energy. I can't say that some of the energy is converted into heat. Okay. Now they didn't ask about that. The question was specific about why the kinetic energy of the air does not all of it transfer or convert to electrical energy. Now, if we assume that the plates have a certain amount of energy and not all of it is converted to electrical energy in the generator, that means there's some energy is dissipated into heat or sound. Okay, and they didn't ask about this question here. Okay, they didn't ask about that. Okay. Next question, question number 3. An object is moving in a straight line with constant speed or constant velocity. Okay, straight line with a constant speed, that means constant velocity. That means the speed is constant and the direction is constant. What do they ask? State 3 ways in which the force may change the motion of the object. Now we know that we have actually any force act on any object, it can do two things. It can change the motion of the object, or it can change the shape of the object. The motion of the object, it can be done by 3 different ways. One of them, speeding up. Yes, exactly. The other one is slowing it down. And the third way is what? Change the direction of motion. Change the direction of motion. And it's only 2 marks. Direction of motion. 1 mark on what? On these 2 parts, okay, together, speeding up and slowing down, and 1 mark for what? Change the direction of what? Of motion. Now, question 3, part B, what do they ask? The figure, okay, here, this figure shows an object suspended from 2 ropes, okay, and they give us the weight of the object 360 Newton downwards, and we have 2 ropes, each one with an angle of 45 from the horizon, okay? So what they ask, the weight of the rope is 360 Newton, and the magnitude of the tension of the rope for each is T. In the space below, what do they ask? Okay. In the space below, okay, determine the tension T by drawing the vector diagram of what? The vector diagram of the forces acting on the object. State the scale that you will have. Now, let me show you something, okay? I'm going to use a device that here has what? An application that we are going to use it that has a pen, okay, and a microscope, okay, that we can take a picture, okay, from what we have here, and we can make a scale. Now, look here. If I have this question, and they ask me to find what the direction of what drawing. Now look here what I'm going to do. I'm going to make a scale, and I will say that the scale each 1 centimeter, okay, it's 100 what? It's 100 what in Newton. Okay, this is the scale that I put it here, okay, because I have 300 Newton what? 360 Newton downwards. So what's happening here? The idea that I'm going to what? To redraw this circuit, okay? Hold on. Like this. I'm going to put the scale as I told you. First of all, I'll bring my ruler, and what I will draw, approximately 3.6 centimeter downwards, but this scale is not the same, it's half a centimeter scale. So I will draw what? 6.2, that means 3.6 times 2, which is 7.2, okay, 7.2 centimeter. This is what? This is our force, and it's supposed to be where acting downwards. Then I will bring my compasses, okay? And when I bring my compass, you know that we have two forces, each one with an angle of how much? Of 45 degrees from each side. Now, let's put it like this, okay? I will draw one of the forces in this direction, okay? That's one of the forces. I don't know how much it is. It's the tension T with 45 degrees, okay? And the other one, it will be also 45 degrees, but where? Going from the top of the object going down, okay? From the top of the arrow, because I have to make a complete circle here, okay? So if I put another 45 degrees, okay, like this, then I'll put it here and I rotate it, okay? You can see that this is my third force. It will be in this direction, like this. Now the point of intersection, it will show me the direction of what? Of the tension forces. So we have a tension force in this direction and another tension force in what? In this direction, okay? So that's how it's our forces. We have to use the ruler. Okay. One of the questions, do we have always to make a triangle? Yes, you have to always make parallelogram or a triangle. So I'll bring my ruler and measure how many centimeters here, okay, which is approximately 5.1. Okay, that means 5.2, that means divide by 2, because I have different scale that to the main scale, and by using the calculator, the force will be approximately of the tension, it will be approximately 255 watt in Newton. So what's the scale that I put here? Who can remind me what's the scale? Yes, it's each 1 centimeter is equal to 100 watt in Newton. I'm sorry for my drawing here, it's not that accurate. Okay, then what I'm going to measure, I'll measure the distance from here to here and put it on the scale, and it will be 255 watt in Newton. So again, let me remind you here what I'm going to do. I'll draw this force as going downwards, and this force that's going downwards, it has to be how many centimeters? 3.6 watt centimeter. Then what? Then I'm going to use what? I'll bring two arrows or two forces. One is in this direction with an angle of 45 degrees. Okay, this is the tension, okay, direction, and one on the other direction, okay, like this, it's supposed to be, and it will be also the same angle, 45 degrees. It will act in this direction. So the point of intersection would show me how much is this force. I'll measure how long is this distance from here to here, and I'll put it on my scale, which is each 1 centimeter. It's equal to 100 Newton. And the answer will be, by measuring this, it will be approximately 2.55, 2.6 centimeters. So that means 255 or 250 or 60 watt Newton. This is the answer. Okay. Any question here? Is it clear? How do we know that the green line is going downwards? Okay. Now, again, we have three forces here. One act in this direction, one act in this direction, one act in this direction. And since they are equilibrium, that means all these forces, they make a triangular shape, okay, or a parallelogram. So we have a force going downwards, and we have what? Another force going in this direction. A third force is going in this direction, okay, to make what? A triangle. Or you can draw it in the other side. Okay, there is a force here, which is equal to this force, okay, and there's another force in this direction, okay, which is equal to this force, like this. Okay, any question here? Tamam. I want from you to try to do it, okay, with your ruler, with your pencil, and protractor, don't forget 45 degrees. Question number 4. The figure shows mercury barometer tube containing of mercury ash is vertical. The height h indicate the value of the atmosphere, okay, pressure. State what is contained in the space labeled X. What's inside here? There is vacuum. There is nothing. Maybe some mercury vapor. Okay, so there is what? Vacuum. Then what they ask, in a particular day, the atmospheric pressure was how much? Was, okay, 1.02 times 10 to the power of 5 Pascal. Okay, 1 times 2 times 1.052 times 10 to the power of 5 Pascal. The density of the mercury is 13,600 kilogram per cubic meter. Calculate the value H indicated by the barometer. Now we know that pressure equal the density of the mercury multiplied by G multiplied by the height. Now the pressure, which is the atmospheric pressure, the pressure at this level, it's the atmospheric pressure, and the pressure inside the tube at this point is now what? Mercury pressure. They have to be equal. So 1.02 times 10 to the power of 5 is equal 13,600 multiplied by 10 multiplied by the height h, by divide by this, divide by that. So the height will be 0.75 watt meter. Exactly. Any question here? Any question? Is it clear? Is it obvious? Okay, next. The tube contains mercury is now tilted. Now we put here this barometer, okay? It's tilted, okay, like this. And there's still what? Mercury inside it, okay? Now they say that it's tilted and make an angle of 10 degrees with what? With the vertical, okay? After tilting, there's contains of the space above the mercury still, okay? A, state and explain whether the vertical height of the mercury of the tube, it will be smaller or same or greater than the height calculated here. I just draw that it's approximately will be the same height. No, it will be exactly the same height because the formula, okay, pressure equal density times gravity times height. The height here depends on the vertical height, not the tilting height. So this vertical height remains the what? Remains the same. So the answer, the same, since we are using the vertical height, the vertical height, okay, and in the formula, yes, thank you, Marwan. In the formula, pressure equal density times gravity times height, both of density and gravity are the same. Both of density and pressure, the atmospheric pressure are the same. I have problem with my pen. I don't know why it's not writing as it's supposed to be. Next question. Another mercury barometer in the same room at the same time shows a lower value of H than the barometer. Okay, suggest what and explain a reason for this lower value. Now we know that, okay, it will not be this lower value unless this was not vacuum. It has some air bubbles inside it. So if we have, okay, if we have some air, okay, here, this air make a pressure on the level of the mercury and move it down. So that's one of the suggestions that we can say that here we can write down that the space X, the space S, sorry, has has some air molecules which create a pressure on the mercury. Next. Question number 5, what they ask. State the values of the fixed point of in the temperature of the degrees. We have two fixed points, the melting, the pure crushed ice here, the 0 degrees Celsius, and the boiling water, okay, of pure water, 100 degrees Celsius. So 0 degrees Celsius and 100 degrees Celsius. These are the two fixed temperatures that I have to mention them. These are the two fixed temperatures. Then what they ask, the graduation, okay, I'm sorry, the graduations on the on the liquid and glass thermometer are equally spaced. For the equal spacing of the graduation, okay, to be correct, state, I have to mention an assumption that may be made for the liquid and another assumption that makes the structure of the thermometer to have to be linear. That's why they are equally spaced. That means they are linear. So what I have to say about the liquid here, it expands uniformly. It expands uniformly, okay, with the temperature, okay. Now, number 2, about the structure of the thermometer, the Calibri tube, okay, the tube, okay, has constant cross-section area, because it's linear. But double I, what they ask, we have two thermometers, thermometer A and thermometer B, and they said that thermometer A has greater range than thermometer B. Let's assume that this is thermometer B, okay, and I have thermometer A which has greater range. Now we have two ways to make it has a greater range. It can be longer, okay, or it can be it can be thicker. The tube here, okay, will be will be thicker for So state one way of the design from thermometer A is different. It is longer. It is longer than B. As simple as this. Then what they ask here, the liquid in a glass thermometer C has has a greater sensitivity than liquid in thermometer D. When we talk about sensitivity here, we have to talk about exactly State one way is that the thermometer C is different. Yes. Aha, a lot of you give me the correct answer, bigger bulb. Okay, bravo. What else? Maybe it's thinner. Yes, the tube is supposed to be thinner. Don't say thinner. The tube is thinner. Okay, so we can say that the tube is thinner. The tube is thinner. Or you can say that what? And has bigger bulbs. And has bigger bulb. Okay. Yes, maybe it can contains alcohol instead of mercury. Yes, thank you. Thank you, Marwan. iPhone, if you please write your name. Okay, iPhone. Okay, what happens to if there is more liquid inside? If there is more liquid, it will not be sensitive. Okay, more liquid, that means it will be expands better. And yes, maybe if we say that it has more liquid, okay, change something, but it will not change the sensitivity here. It will change the range or the okay or something else. Okay, you are welcome. Now, in part C of this question, in the space below, okay, provided, draw a label diagram for a thermocouple. Okay, now we know that the thermocouple has a voltmeter, and this voltmeter, it has two copper wires, okay, that come out from it. So this is copper, and each of these copper wire, okay, it has a junction with what? With a third wire, for example, okay, this is the junction, okay, for example, with the constantan or with iron, okay. Yes, thank you, Muhammad. Okay, and if they didn't ask to measure how to measure a certain temperature, okay, I need to tell them that I will put one of this what junctions, okay, or inside what crushed ice. Here we have to put crushed ice, okay, that has 0 degrees Celsius, okay, crushed ice, okay, ice at 0 degrees Celsius, and this cold junction in this situation, cold junction, and the other junction we have to put it where? On the thing that we need to measure its what? Its temperature. Okay, good. Now, then what they ask here, they tell us, okay, suggest when the thermocouple thermometer is more suitable than the liquid in glass thermometer. Now we know that we can measure, use the thermocouple to measure the temperature of things that they have rapid change in their temperature, like okay, or they have a very high temperature, like lava, or they can pass through small holes, like when we need to measure the temperature of an oven, which has a greater temperature than what 300 degrees Celsius. So we can write here, okay, when the range of temperature is too high, the range of temperature is too high. Yes, no, I can't say about boiling point, okay, because boiling point is only 100, and when we talk about thermocouple, okay, to have a higher temperature or wide range, it's supposed to be above 300, 400 degrees Celsius. Like lava, the temperature of it between 2000 and 6000 degrees Celsius, okay? I'm talking about 1000 degrees Celsius, too high. Any question? Did I answer your question? Okay, you are welcome. Right, next. Question number what? Number 6. What do they ask? Look here. An electric heater, okay? An electric heater is placed in the floor, okay, of a room inside a house. The heater is switched on, okay? State the main process by which the thermal energy is transferred in air of all parts of the room. Now, because we are talking about air, that means we are talking about fluids, and how do the heat is transferred through fluids? Thank you, Muhammad. Another answer. Bravo. Convection, not convectional, convection. Convectional current, yes, is correct, but convection, it's all, this is correct answer because this is the process of how the heat is transferred. Then what they ask here, the heater has a power of what? 1.5 kilowatt. Now, when we said kilo, that means 1,000, so it's 1,500 watts, okay? And the air inside the room has a mass of how much? 65 degrees Celsius. The specific heat capacity of what? Of the air, C, okay, 720 joule per kilogram degree Celsius. I. Calculate the time. They ask about T equal question mark, okay? Okay, for the heater to raise the temperature in the room from 8 degrees Celsius, this is the initial temperature, to what? To 15 degrees Celsius, this is the final temperature. Now, what is the formula that we know? We know that energy equal mass times gravity times specific heat capacity time change in what? And temperature. Now, since we don't have energy here, we have what? Power. So power times time, okay, equal the mass times specific heat capacity times what? T final minus what? T initial. So what I'm going here, I'm going to substitute the values, the power, which is 1,500, multiplied by T, that what we want to find it out, equal the mass, which is 65 kilogram, it's written here, multiplied by specific heat capacity, which is 720, okay, multiplied by the change in temperature, which is only 7 degrees Celsius, 15 minus 7, then divide by over 1,500 over 1,500, and the time will be 220 what? Seconds. 200 what? 20 seconds. This is the time that we have to expect it to what? To heat the whole room of by this amount of air, only from 8 to 15 degrees Celsius. Now, usually in any question about thermal physics, our calculations are not accurate because of some energy is not transferred correctly here. What do we have here? A question. They ask about what? State 2 reasons why the time calculated, okay, is smaller than the actual time taken by the raise of the temperature in the room from 8 to 15 degrees Celsius. Now, actually, we are not, the heater here, it doesn't heat up the air only. Yes, thank you, Muhammad. Some if the energy is what is heated up, okay? I'm sorry, yes, I'm sorry. I said 8 and I wrote 7, okay. So, yes, thank you. No, it's my mistake. Shukran ya Nada. So you can see that here, as one of you told me, that some of the energy is escaped from the draughting of the air onto the other room, because we are talking about some. This is a room, that means there is some air entering it, okay, from another room, okay. So that means also that not all the energy is transferred, okay, to only the air. Maybe the furniture, maybe the walls, okay, it's heated up, okay. So we can write down some of the energy is used to heat the what? The walls, okay, and the furniture, for example, you can say furniture. That's reason number 1. Reason number 2, you can say some energy is used to heat the air entering the room. The air entering what? Entering the room. Okay? Yes. Aren't they technically the same? No, it's not the same. No, it's not the same. Okay. Okay, thermal energy used to heat the air that enters the room. Yes, thank you. Thank you, Abdurrahman. And heat lost to the surrounding. Okay, that's another answer. If I'm not talking about a room that may be insulated, maybe not insulated, I'm not sure that it goes outside. But the word surrounding, I change it from the walls or the furniture inside the room, okay? Or the ceiling or the window, whatever. Good? Did I answer your question, Saja? Tamam. Question number 7, it's very easy question, I remember it. And what they ask here. Okay, in the figure here, okay, a small circle represents molecules. The arrows refer to the change in state from the arrangement of the molecules that left, okay? What was the change here in X? Complete the words, solid, liquid, or gas. Okay, the change here, what it was from what to what? Yes, it's solid, bravo, it's called melting, to what? To liquid, exactly. And the second one, it's obvious that's from liquid to what? To gas. Bravo. Okay, very easy, 2 marks. Then what they ask here, part B, explain in terms of the force between the molecules, okay, why gas expands more than what? Solid, when they are undergoes with the same rise in temperature. Actually, we know that gas molecules have what? Weaker what? Attraction force or attractive forces, okay? Attraction, weaker attraction force between its molecules. So it is easier to move them further by heating. Than solid. Okay? Easy? Any question here? Okay. Next question. A cylinder of volume V1, okay, 0.012 meter cube, contains compressed gas at a pressure of 1.8 times 10 to the power of 6 Pascal. A valve is opened until the compressed gas is escaped from the cylinder into the atmosphere. The temperature of the gas doesn't change. Calculate the volume that escape from the container. Look here, ya shabab, sabaya. We have this container and it was sealed and there was gas inside it. Okay, now when we open it, what will happen? Some of the gas, okay, is escape out and some of the gas remains inside. Okay, that's why they use the word escape. So 3 marks. First of all, we have to use the formula P1 V1 equal P2 V2. Okay, and we know that the volume here, it's the volume 1, okay, which has a pressure of 1.8 times 10 to the power of 6 multiplied by 0.012, which is equal to the pressure in the second situation, which is the atmospheric pressure, 1 times 10 to the power of 5, multiplied by the second volume, and the second volume, it will be V2. By using calculator, V2, it will be equal 0.216 meter cube, okay? That means the volume of the whole air, okay, or the whole gas in and outside, in the cylinder and outside the cylinder. They didn't ask about how much the final volume, they ask about how much leave. That means the volume here, there's some amount of volume remains, which is 0.012, and some of them leave. So the difference in volume, which is equal, what? 0.216 minus 0.012. So that means the volume which is escaped, which is approximately how much? 0. What we can say here? Here 4, here 1, 2, 0, 4. So the answer approximately, you can write it 0.21 or 20, okay, cubic meter. Hold on. If we put here, if we switch this value to 2 significant figure and we make it 22, okay, and we subtract it by this value, which is 0.012, that means we get an answer of, okay, of 0.21. Okay, so don't forget to write the unit, which is cubic meter. Any question? Is it clear here? So this is the first part, we get 2 marks on it, and this is the second mark to find how much the escape, that means the difference between the volume before or after, how much of the gas get out from what? From the container. Next, question number 8. What do they ask? The figure shows a parallel wavefront of light of wave and ice. Okay, the wavefronts are incident the boundary with air. Okay, the speed of light and air, we know it's 300 million meters per second. Okay, 3 times 10 to the power of 8 meters per second, and the refractive index of the ice is 1.3. Okay, on the figure, draw the wavefronts. Okay, draw arrows to show the direction of the travel of the waves that refracted in air, and label what the arrangement incident with label the angle of incident and the angle of refraction. Now we know that according to the 6 S's that I told you about shallow water, the speed becomes slow, yes, and the wavelength becomes short, etc., and the angle becomes small, etc. Okay. Now what do we have here? Now since the angle becomes small, that means in the ice this angle would be small, and this angle actually is the angle of incident. What will happen to the angle as it travels to the air? It becomes what? It becomes bigger. So it will be like this. This is the angle of what? Refraction. Then I'll bring my ruler and draw waves like this, parallel lines. Okay. By eye, forget my drawing is not that accurate, but it's supposed to be parallel lines. These lines with the ruler. Okay, that's what the direction, okay, of the light where it's travel, and you know that in air it travels faster. This is the arrow that represents the direction of incident ray, and this will be the direction of the what? The refracted ray. Okay, that means you have to draw them that it's 90 degrees perpendicular to what? To the refracted rays. Okay, this is okay refracted direction. Now, what they ask, one of the question, okay, sir, isn't the angle of incident with the normal? Okay, do we have normal here? We don't have normal. So if I want to draw a normal, if I want to draw the normal at one of the points, okay, this is the normal, for example. Okay, that means this, okay, this is the direction of the arrow. This is the angle of incidence. Okay, this is the incident ray. This is the angle of incidence. Okay. And this is the angle of what? Refraction. It will be like this. This is the refracted wave, and this is the angle of what? Refraction. But they didn't ask us to draw a normal. Draw the wavefronts, okay? Draw arrows to show the direction of the wave travel, okay? And label the angle of incident and the angle of what? Refraction. If I put a normal, I can do that, but I know that this is the angle of incident and this is the angle of refraction, and the angle of refraction, according to the 6 S's that I teach it to my students, okay, the angle here in the air, it will be bigger because it speeds up in the air, it's faster in the air, the light waves. Okay, did I answer your question? So it's not necessary to draw it with red, okay, as it's necessary to draw it as they ask us from us. Okay, you are welcome, no problem. Then what they ask, calculate the speed of light in ice. Now we know that refractive index equal C la V. Do you remember when I told you C la V? Okay, tu parles français. C'est bien. So refractive index equals C over V. They ask about V, which is the speed of light where in the ice. So V equal C over N, which is equal 3 times 10 to the power of 8 divided by N, which is given. How much is this? 1.3. And by using the calculator, our answer will be how much? 2.3 times 10 to the power of 8 meters per second. Any question here? Any question? Okay, let's move on. Question number 9. It's about electricity, and usually I love questions about electricity because there are a lot of ideas. They are easy. Okay, now what they ask here, the figure shows the current voltage, a current potential difference. Okay, graph with the resistance of what and with a thermistor. Okay, a fixed resistor, it's a straight line, and the thermistor, it's a curve, and we know that the y-axis is current and the x-axis is the voltage. Calculate the resistance of the thermistor when the potential difference across it is what? 7. Now here, when it is 7, That means we know that V equal IR. That means R equal V over I. So the voltage is 7 and the current is how much? Okay, in this situation, the current is 4.6 exactly. Now 4.24685. Okay, that's between 4 and 6. So the answer by using calculator, it will be 1.5 watt ohms. Then what they ask here, they said that in the table, tick the boxes that indicate the effect of the resistance of the resistor and of the thermistor when the potential difference increase from 0 to 7. Now we can see that the resistor is a straight line. That means the resistance is constant, while here it's curve. And we know that the gradient of this curve is different than the gradient of this curve. It decreases. And since we are talking about I, the gradient I over V, which is 1 over R, that means whenever the gradient here is more, that means the resistance what decreases. So the answer is for the thermistor. As we know, as the temperature increases, the resistance of the thermistor what decreases. Okay. Any question here? Is it clear? Okay. Now what they ask. The thermistor and the resistor now are connected in parallel to the 7-volt supply. In parallel, that means each one of them has 7-volt what? Okay. Calculate the current of the what supply. Now, we know that at 7 volts, both of them, they have the same what current, which is how much? 7.6, right? So that means since they are in parallel, the current total, it will be equal the current through the resistor plus the current through what? The thermistor. And it will be 4.6 plus 4.6. And the answer will be 9.2 what? Ampere. Next, what do they ask? Calculate the energy transfer from the supply in how long? In 5 minutes. Now we know that energy equal very important time. The voltage here, which is 7, multiplied by the current, which is, we just find it out, 9.2, multiplied by the time, which is 5 minutes. We have to convert it into seconds. Who can tell me how to convert the time from minutes into seconds? What do we need to do? We need to multiply it. Exactly. Thank you. Multiply it by how much? Multiply it by what? 60. And by using the calculator, our answer, it will be how much? Our answer, it will be 19,000 joule. Okay? 19,000 joule. Any questions so far? Now let's move on to question number 10. In this question, okay, what they ask, look here. The electrical what energy produced by the power station is transmitted over a long distance by what? A very high voltage. Long distance, very high voltage. Explain why, explain why a very high voltage is used. This is February or March 2019. I send it to you on the schedule. Okay, explain why a very high voltage is used. Now, we know that whenever we use a step-up transformer to increase the voltage. And as we know that whenever the voltage is higher, the current is what? Is lower because we are transferring the same amount of energy. So let's assume that I'm transferring $1,000. Okay, now I can send it 10 papers. Each paper, it's a $100 bill. Okay. Or I can send it $1,000. Each one is $1, $1, $1, $1, $1. Okay, so let's assume that some of the energy is dissipated or lost during what the wires. So if one of the bills is lost, okay, one of the paper lost, and it was cost 100, so that means the amount of energy lost is 100 out of 1,000. But if I was having $1, $1, $1, and maybe I lose 1 or 2 or 3 or maybe 20, it's still nothing is lost compared to what? To the original value when the voltage was low. So as the potential difference is higher, that means the current, it will be lower. And by using lower current, that means the power dissipated as heat, it will be lower according to the formula P equal I square R. I'm going to write it down now. So that means that the cable okay, resistance, they will be having lower what current. So I will not use that much expensive wires, okay, or thick wires to have this huge what current to pass through M. Okay, so increasing the potential difference causes the current to be low. So the power dissipated by the cables are low due to power equal I square R. So the cables can be thin and what? And cheap. Thin and cheap to transfer low currents. 3 colors, 3 marks, 3 ideas. Part B from the figure, we are talking about transformers here, okay, that we have an input voltage for the primary, okay, and output voltage between A and B for the secondary coil. The figure represents a transformer, okay. What they ask. The primary coil has 4,000 turns, okay, and the input is 120 volt, and the secondary coil has what? An unknown number of turns with 9 voltage. So what they ask, calculate the number of the turns in the secondary coil. We know that we have something called transformer ratio. The transformer ratio states what? The voltage of the secondary over the voltage of the primary. It's supposed to be equal the number of turns on the secondary divided by number of turns of what? Of the primary. So this is the formula that I'm going to use it. I will substitute the values, okay? The voltage of the secondary, which is 9, divided by the voltage of the primary, which is 120, is equal to the number of the secondary turns, I don't know, they ask about it, divided by the number of turns in the primary, which is 4,000. By doing cross multiplication, by using the calculator, the number of turns will be 300 what? Turns. Thank you, Anfal, yes. Thank you, Anfal. Clear? So this formula called what? Transformer ratio, we have to know it, okay? And they usually ask about it in multiple choice question or paper 4 question. State a suitable material for the iron core, for the core of the transformer. This core, okay, is supposed to be milled by a temporary magnetized material or permanently magnetized material. Okay, temporary magnetized material, which is what? Iron, exactly. I'm sorry, I said iron. Okay, thank you, a lot of you. Saja, Ahmad, and Anfal, Marwan, all of you, and more, they send me the correct answer. It's supposed to be iron. Last question, okay, for this paper. What do they ask here? Okay, look here, what they ask. AI, one isotope of iridium 194 is represented by IR 77194. This isotope decay beta emission, okay, to a stable isotope platinum PT, okay? Complete the nuclear equation for this decay. Now we know that beta, it's -1 since it's an electron, and it doesn't have a mass, okay? Or its mass is negligible. So to make this equation correct, we have to know that the arrow, it looks like an equal sign. So 77 equal how much plus minus 1? It will be exactly 78. Thank you, Adam. Thank you, Muhammad. Okay, and the same thing here, the platinum here, it will have the same what? Nuclear number, because the nuclear number for beta is 0. So that's easy 3 marks. Look how easy it is. So you have only to what? Do simple math here. The top number here, the nuclear number, it doesn't change, but the bottom number, the atomic number, Okay, it's increased by 1 proton. Next question. What about particles? What do you mean by particles? Saif al-Din Islam. What do you want? Yes, tell me your question. I didn't understand you. Beta? We know that beta, it's an electron, -1, 0, yes. A particle or alpha particle, you mean? Alpha, if it emits alpha, and we know that alpha it's 2, 4, okay, that means I will subtract the 77 by 2, and I'll subtract 194 by 4. So it will be 75 and 190. And that's not platinum, it's another element. Okay? You are welcome. Okay. Okay. Next, what do they ask? The half-life of iridium, okay, 194, is 19 hours, okay? And it has an initial count rate of 1,100, okay, counts per minute. What do they ask? Calculate the count rate of this sample after how long? After 38 hours. Now I'm going to draw a table. And this table, it has 2 variables here. What it is? Okay, first of all, I would say about the count rate, the count in minutes, okay, and the time in what? In hours. So the count rate now, it's how much? 1,100. And the time now, it's 0. Then what I will do, I'll keep adding half-lives, 19 and another 19, which is what? 38. So I'm adding half-lives. But the count rate, I'll divide it by 2, which is what? 550. Divide by 2, yes, 270, what? 5. So 275 counts, what? Per minute. Thank for all of people that they participate and they send me the answer. Last part of this question, state 2 ways in which gamma emission different from beta emission. Now, we know that gamma has no charge and beta is negatively charged, okay? We know that gamma has no mass and beta has a mass of an electron, okay? We know that gamma has lower ionizing effect than beta. We know that gamma has high penetration power, okay, more than beta to pass through metal sheets. A lot of differences you can write them down, okay? So we can say that gamma emission is neutral, for example, neutral, while beta particles, okay, are negative. Okay, you can say that another answer, gamma has no mass, but beta has what? Small mass, okay, or electron mass. Yes, you can say that, Anas. And Jude, yes, thank you. Okay. These are the questions of this past paper, okay? We took a lot of time, okay, to answer it because most of my time was wasting to fix the pen during the class, okay, and fix the charger also during the class. That's it for today. If you have any question, you can stay online, okay? If you don't have a question, you can leave, okay? And if you want to ask me a private question, you can send me on my number, okay, on the WhatsApp, which is 96279, okay, 982, okay, 8524. Have a nice day. See you next session إن شاء الله. الله يعافيك وشكرا لك يا زين ويا زيد ويا سيف ويا أدهم. You are welcome. Okay. Can I get the answer for 10B? No problem. Yes. Yes, Jumana, what's your question? For question 10B, I, this one, double I, this is iron, and this is I. Yes, you want question number 9, no problem. Now I'm going to, okay, you are welcome. Question number 9, which one? Part B. Okay, the resistor has constant resistance, while the thermistor has decreasing resistance. Did I answer your question, Jumana? Any other questions? الله يعطيكم ألف عافية.